comparing the means when the samples are dependent. So when we are using dependent samples, we call it as the match pairs t-test. So previously, when we use independent samples, we call it as the pool variance t-test. So now, when using dependent samples, it is match pairs t-test. So in this case, we are interested in only one variable, which is the paired difference, d subscript I, between measurements for each person or object. So d subscript I is going to be equals to x1 minus x2, whereby x1 and x2 are the paired observation. So example, if you want to look into the difference between the test score for students before joining the tuition and after joining the tuition. So x1 will be for D1 will be the first respondent test score before joining tuition and test score after join tuition. And we can also have D2, which is for the second respondent. It's his or her test score before join the tuition and test score after join the tuition. So the major advantage of using dependent samples is that we can eliminate the individual differences that occur between person or object, and this will increase the power of test. So since we are using this is because we are using the same samples for the same person for both samples. So again, when we want to compare uh, the population mean between the mean between two population for dependent samples, it's the same whereby we have two tail test and also one tail test. So for stating the null hypothesis, it's going to be H null mu D equals to 0, whereby this mu D is the mean of the paired difference, and the H null or H1 is going to be mu D not equals to 0 for two tail, one tail if it's less than 0 and greater than 0. So the steps in constructing the hypothesis testing is the same. We need to state the H null and H1, alpha, and also the test statistic. So in this match pair t-test, the test statistic is going to be xd bar minus mu d over sd over square root of n. So what is xd bar? It is the summation of di over n. And SD is this formula. So we have this 1 over n minus 1, the summation of the squared, and also the summation of di squared and then over n. And here the degrees of freedom is going to be n minus 1. So n here is the number of pairs of observation. So here we assume that the distribution of the population of difference, which is the d, follows the normal distribution. So example, an accountant is in the process of investigating the consequences of switching to another method of depreciating assets. So she randomly selects 6 firms and calculates the after-tax profit using both differentiation methods, and these are the results. So we have the same company, same firms in the sample, so it's going to be dependent samples, so 6 firms, and this is method 1 after tax profit differentiation method, and this is method 2. So we have the same firm using both methods, so it is a dependent samples, and the claim is that do these data provide sufficient evidence to indicate that adoption of method 2 is giving them lower after-tax profit, and we want to test this claim at alpha equals to 0.05. So in this statement, okay, it wants you to prove that the after-tax profit using the second method is less than the first method. So here we need to define the difference between the first method and the second method. So we know that the difference, it might be mu1 minus mu2, or it can be it can be x1 minus x2, or it can be also x2 minus x1. So since it says in the question that method 2 gives or results in the lower after-tax profit, so meaning that method 1 will give you higher after-tax profit. So if method 1 minus method 2, then it will give you a positive difference, because we are claiming that method 2 gives a lower tax profit. So D here, the difference in profit using method 1 minus profit using method 2. So we have the result for method 1 and method 2. So we need to subtract method 1 minus method 2 for each firms, for all the 6 firms here. So if you look back at the example, at the question, we have this method 1 for company A, 90 and 84. So we need to subtract 90 minus 84, 18 minus 20, and until 40 minus 25, because we are saying that method 2 is lower than method 1. So when we claim that method 1 is higher, so the difference, we are saying that it's going to be larger than 0. So by saying that difference is larger than 0, so the H1 or alternative hypothesis will be mu D larger than 0. H null mu D equals to 0. H1 mu D larger than 0. Why is it larger than 0? Because we are using the claim that method 2 will give you lower after tax profit. So meaning that method 1 will give you higher tax profit. So method 1 minus method 2 definitely will give you a positive difference. So this is alpha level using 0.05. So in this match pair t test, we need to calculate xd bar and also sd. So what is xd bar? It is the summation of di over n. So di is the difference, so you need to add up all the difference that we just calculate. So it's going to be 6 plus minus 2 plus 6 plus 7 plus 0 plus 15 divided by 6. Same goes to ST, we need to calculate with this formula. So if you look at this formula, this is the summation of di squared. So meaning that you need to square each of the di and then sum all the di squared. And this is the summation of di, square it. So once you have the test statistic, replacing all the values, you get 2.181. So you need to find the critical value. Always from the test, once you get the test statistic, you need to find the critical value. So the critical value will be from the table, which is from the T table. So it's going to use alpha and also degrees of freedom. So degrees of freedom for t-test is going to be n minus 1. So what is here? This is referring to alpha 0.05. Why we just use 0.05? Because it is a one-tailed test. So for one-tailed test, you don't have to divide by 2. So referring to the t-table, it gives you 2.015. So since this test statistic is larger than 2.015, so we reject H null. So meaning that we can conclude there is enough evidence to indicate that the adoption of method 2 results in a lower after-tax profit. So we are rejecting H null, and we are saying that the difference will be larger than 0. So meaning that method 2 will give lower than method 1 after tax profit.